Hi everyone, welcome to SKM Academy. In this video, we're going to see Physics 12th Chapter 1, Exercise 1.15. So the question is, what is the net flux of the uniform electric field of exercise 1.14 through a cube of side 20 centimeter oriented so that its faces are parallel to the coordinate planes? So in the last question, that is exercise 1.14, we have found out the flux of the field through a square of 10 centimeter on a side. So here they are asking for the cube. For a cube, what is the net flux? So see, so this is a cube. So for this cube, the electric field is given in the direction of from left to right direction, and the electric field is 3 into 10 to the power of 3. So that is taken from the last question. Say the question is here. So the uniform electric field is E is equal to 3 into 10 to the power of 3 I cap Newton per meter. So it is along the x-axis. And then we are going to draw a normal for each face. So if this is the normal and this is the electric field direction, so here the angle between the normal and the electric field will be 90 degree. Like that, for this face, both the electric field and the normal will be parallel. So the angle will be here 0 degree. Like that, for this face, the normal and the electric field will be perpendicular to each other. And for this face, the normal and the electric field will lies in opposite direction. So that is anti-parallel. So for anti-parallel, the angle is 180 degree. So we know that the electric flux E is equal to electric flux phi is equal to E dot A, or otherwise E A cos theta. And the area means, which is the side square, so 20 centimeter square, which can be written as 0.2 meter into 0.2 meter, so which will gives you 0.04 meter square. So for the top and the bottom phases, the normal and the electric field are perpendicular to each other. So that for top and bottom face, the angle will be equal to 90 degree. So flux on the top, which will be EA cos 90 degree, which will gives you 0 value. So cos 90 degree is 0. Like that, for the flux through the bottom, which is EA cos 90 degree, for this case also the flux will be 0. And next we are going to solve for the flux through the front and the back faces. So for the front and the back faces, here for the front side, the angle is 0 degree, and for the back side the angle will be 180 degree. So for front and back faces, so which are perpendicular to the x-axis. So flux through the front, which is equal to EA cos 0 degree. So cos 0 degree value is 1. So E dot A, and the flux through back face, which is equal to EA cos of 180 degree. So cos 180 degree value is -1. So minus E dot A. So here they asked to find out the net flux in the cube. To find out the net flux, we have to add all the flux. So flux on the top, flux on the bottom, flux through the front face, flux through the back face. So the values of, for the top flux is 0, like the bottom flux also 0, and the front flux is E dot A, and the back flux is minus E dot A. So the net flux will become as 0. So thank you for watching. We see in next video.